We spend so much time in a calc class teaching students how to take derivatives. In my opinion, the fun begins once you know what these derivatives can do. The first application for most calc students is typically finding where functions have relative minimum values and relative maximum values. Before we get into that, let's review what you should know already about the relationship between a derivative and what the function is doing. So if you're at a particular point, x equals c, and the sign of the derivative is positive, that means by definition that the slope of the tangent line is positive. It also means that the function itself is increasing at that particular x value. Similarly, if the sign of f prime at x equals c is negative, then by definition, the slope of the tangent line is negative. And it also means that the function is decreasing at that particular x value. Finally, perhaps the most important part is when the sign of the derivative at x equals c is 0. Well, of course, the slope of the tangent line is 0, horizontal. So the function is neither increasing nor decreasing, but this is where you will find the relative min or relative max for a function if one exists. So I'll show you something on Desmos in just a moment, but we're going to consider the function f of x equals x to the third minus 3x squared. And just to investigate, let's take the derivative and we'll set it equal to 0. We'll factor it. And we'll find out that x equals 0 and x equals 2 are actually very special points on our curve. Let's look at the graph first to see what we can infer from this. So here's the graph of f of x equals x to the third minus 3x squared. I've constructed a slider that shows us what the function is doing and what the derivative is doing at particular x values. Notice that before x equals 0, the slopes of the tangent lines are positive. The function is increasing. When I hit x equals 0, that one particular critical point we mentioned before, one of the two, notice that the derivative is 0 and thus the tangent line is flat. We can keep moving and find that after 0, the slope of the tangent line is negative. The function is decreasing. So let's review that again. Positive tangent line, flat, negative tangent line. Increasing, flat, decreasing. That, of course, indicates the presence of a relative maximum. All right, and if we continue into the future here, we have negative tangent lines, a decreasing function, and then flat behavior at x equals 2, and continuing on, positive values for the tangent line, and the function is increasing. Review that again. Negative tangent lines decreasing, and then flat, and then increasing is the presence of a relative minimum. You can see it's the lowest value of all the points around it. Here's the highest value of all the points around it. Now, it's not what we call an absolute maximum for this entire function. That's an entirely different concept later on in calc, but they're just relative minimums. In other words, relative to the points around them, this point is the largest, indicated by derivative is positive and then negative. And then at x equals 2, this is a relative minimum. It's the smallest of all the points around it, where the derivative was negative before and positive after. So going back to our scratch pad here, you would technically construct a sign test for f prime. You would put your two critical values on there, and either using algebra or what you know about second degree functions, you could conclude the behavior of f prime is positive, negative, positive. And since we go from positive to negative, this must be a relative max at x equals 0. And since we go from negative to positive, this must be a relative minimum. Now, the problems are ranging in difficulty from very easy like this one to very difficult. But like anything in calculus, it's important to know the procedure is always the same. The problems can increase in difficulty, they can increase in complexity, but the principles are always the same. So if you would like to see a more difficult problem, if you have one you're working on, let me know in the comments. I'm trying to build this channel based on clearly explaining math helping people get through those hurdles when calculus is difficult, when other math courses are difficult. I'd appreciate any engagement, liking, commenting, subscribing, as I attempt to build this channel and be a resource for as many people as would like to get enjoyment out of math. So I hope you enjoyed the video. Hope to see you soon in a future video. Thank you.